So we don't want to wait any further. So we were waiting for Dr. Nekbat being the supervisor of the PhD students. So I think we should start right away. Is the presentation ready?
Let's go.
I could see also because of changing the time and the date and the usual Monday, not the usual students are there. Some of them we're missing them. Okay, anyways, excellent. So Arash, the floor is yours. Please proceed.
All right, sure. I'll just start. Hello, everyone. My name is Arash. Today I will be presenting my topic on semantic integration of BIM and BMS for automated fault detection and diagnostic of HVAC. My research is under the supervision of Dr. Nekbat. On today's agenda, I'll start with a brief introduction, and then it will be followed by goal and objective of the study and the methodology and applications that are adopted for this study, and then we'll have a brief discussion of the results. So first of all, I would like to start with why do fault detection and diagnostics in HVAC matter. With more than 1/3 of the total energy use is associated with building energy. Within that, 50% is associated with HVAC in the systems, and 15% within those faults are basically reducing the energy efficiency when faults are detected within a HVAC system. So when I'm referring to the faults affecting, faults are basically appearing in the system, that is fault detection when once the fault is being detected, and diagnostic is basically the type of that faults that is found in the system. This is not the only problem that fault detection is having. Not only impacts the consumption, basically it impacts on the occupant comfort and the downtime of the system HVAC itself that can cause further problems. Now, how fault detection and diagnostics are basically happening within buildings? There are mainly three categories how fault detection and diagnostics are basically done by analyzing the literature. Well, on the left-hand side, you can see the calibrated simulation. This type of fault detection and diagnostics use the a priori knowledge, the physical knowledge of the system, and basically have some context to it for fault detection and diagnostics. As we tend to come towards the right-hand side, where my research area is being focused, gray boxes and black boxes, they tend to use more of data and basically lose on the context part of it. I call this area automated fault detection and diagnostics of HVAC. And the problem that basically is being faced here, we don't have any information. I will get to what type of information that I'm losing onto, but luckily for me, within my research, I found that BIM as a knowledge source can contribute to this type of missing information. So basically the BIM, as you might know, some of us are mainly thinking as a 3D model, but what I'm referring to here is it consists of entire life cycle of information of this system HVAC. It is mechanical, electrical, plumbing, and within that, the contextual information that we were talking about, it can include the HVAC schedule, it can include the parameters associated with the building, the spatial information, the HVAC catalog information. So generally in AFDD models, we tend to lose this sort of information. This is the overview of my entire research that I'm doing. I've found out two integration methods that was found based on the literature analysis that are basically able to bring the static information, the contextual information from BIM, the dynamic, the sensory data that are needed for data-driven studies to the integration database, let's say, call it a database. So ontology and ontologies or ontology and databases can be used to integrate these, and further they can be queried or visualized to get the information for AFDD. These are my overall 5 objectives that I've brought in for my PhD research. Students' focus would be on my fourth objective and fifth objective, where I will be looking at how knowledge modeling is done for the data-driven models, including the BIM part. And then on my fifth objective would be how to semantically integrate these data-driven FDD models with BIM. In terms of semantic world, the objective 4 will be called as T-box, and the objective 5 would be called as A-box. Think of a T-box as a schema, empty schema, and A-box is a populated version of that schema. So basically, in the fourth objective, I'm creating the schema where the information can be brought in, and the fifth would be how basically they are introduced in the model and can be accessed. Before we dive deeper, let's see what is an ontology. Ontology itself is an artifact of a domain. Basically, it captures the conceptual information of a domain. Where we are talking about our domain, in my case, it's HVAC. So basically, it can have all the type of HVAC system, the subsystem, the elements, the parts that are included as a family together. That's called as a terminology. Once I put it on a hierarchy, creating a dictionary of it, let's say what types belong to what type of systems, then I'm forming a taxonomy. Now, how these HVAC system, the parts, the building parts are associated together, what type of relationships are being formed between those is the ontology relations. Basically, so ontology enables me to capture a concept, in my case, HVAC, and show me what includes, what concepts are there, how these concepts are related together, and what type of restriction between these axioms are existing. This is my entire AFDD ontology development steps that I've taken. I will not be going deep into all of them, but how I've created the taxonomy development is basically using the literature analysis, basically going to the standards, using the guidelines. I have extracted the type of HVAC system, the type of faults, the type of algorithm, and how they are interrelated with each other. And in the next step, I've looked at how I can use the existing ontologies in the domain. So the existing ontologies, when I refer to ontologies called as upper ontologies that are basically readily, we have all the concepts available and that can be reused in my ontology, which I'm calling the AFDD ontology. And then mapping the ontologies with basically my BIM, how it is converting from IFC to the AFDD schema that is converting it from IFC to IFC all, and then creating mapping between IFC all and the AFDD ontology, and again from BMS system to the AFDD ontology. As I said, our focus of today would be how to populate those AFDD ontology, and then looking how we can test and validate if we are able to answer the questions that the ontology is developed for. These are the 10 main concepts that AFDD ontology is having. Some of them to just name are element, type of faults, type of algorithm, the interface of it, the maintenance, and the information associated with building and HVACs. Now, some of the information are basically brought in from BMS system, and the other information are from BIM. So these are where these concepts can be brought in, and the type of relationship between these concepts, the axioms are on the right-hand side, basically, each of these denoting how these concepts interrelate to each other and what type of constraints are available in this AFDD ontology. Now, this is the overview of how the AFDD ontologies looks like. On the left-hand side, the lighter circle you see is basically the AFDD ontology concepts that are introduced solely for AFDD ontology. And as I said, upper ontologies are used. The main two ontologies that I brought in is DOT ontology, the brick ontology are basically the upper ontologies that I have reused for the case of AFDD. There are certain mappings between the brick ontology and DOT ontology, and you can see the object properties that are reused again from the existing ontologies and the ones that are needed for to answer the AFDD questions that are having. And in this slide now, I'm showing you the statistics of how this AFDD is being developed. Usually, developing an ontology is an iterative process. So you develop certain questions that you want to answer, and you get to that, and you do not want to overdo it. So my ontology, the AFDD ontology can only answer certain questions, and I tested for those. So initially, I started with a high number of exams, more than 7,000, and then reduced it to 1,400 on top, which is, I have reduced it for exactly what questions I needed. To increase the expressivity of the ontology, I've increased the number of class counts and the subclasses. So the expressivity of the ontology has been increased. And on the bottom side, you can see basically the axiom, the restrictions, the cardinality restriction between the concepts have evolved throughout development stages. Now, AFDD ontology can be found online on my GitHub page. Basically, can be reused further. You can extend it, and it is available in different serializations. Basically, can be has the different classes, the object properties. Now, following, you have seen already the AFDD ontology, how it has been created, what concepts are in that, and type of the relationships basically that are governing between those. To test and validate an ontology, there are certain metrics that can be used. In my study, I'm looking at 4 metrics. Today, I will be talking about the first 3, that is competency, consistency, and completeness of an ontology. The approaches that I'm looking is, I have developed a competency question for a case study, and then I have done automated consistency checking using a Hermite and pellet reasoner. Further, the competency questions are translated to Sparkle queries and created a Blaze graph, knowledge graph to extract those information to check for completeness of the ontology that is being developed. So the specification of an ontology, first of all, the AFDD ontology only looks at building commercial, the commercial buildings HVAC. The purpose of it is to create a digital twin for the HVAC that can basically allow the users reuse and create new FDD models for their existing buildings or a similar portfolio of assets that they might be having. These are some of the competency questions. They are not full exhaustive list of the competencies, just to say what type of question that can be asked. Like you are able to ask the parameters used for a specific type of algorithm, the faults that are associated with an HVAC, or basically the spaces that HVACs are consisting, the relationship between the HVAC and so on. The case study that is being developed is called as a flexible research platform, called as FRP, looks at the 1980s era building, which has 2 floors. It has R2 on the roof and consists of 10 VABs with reheat coils, and architectural model, mechanical model are created for it, and the spaces and information, space-related and zone information are added to them. And this is basically the part that BIM is contributing to the AFDD ontology. Now we will be looking at what information can be brought in from the BMS. Basically, I've used the BMS data set that is including 7 types of fault that were there in the data set. The data collection frequency was every 1 minute, and it was done over months period of time. Totally, 4 models were created for doing the analytics on the BMS, and 2 machine learning FDD models were created. One is neural network, and another one is the SVM model. This is, I don't want you to get into detail how this looks. Basically, once we have those BIM information that I've shown on the first page of slide of the case study, and the second one from BMS, once they are populated into the ontology, this is the A box, how it looks, how it looks once it is populated. Further to do the second, basically testing for consistency, Hermite reasoner is used, where it looks at 2 type of basically information. One is inconsistency, if exists within the ontology, and inferences based on object properties and even classes. So this is once if an ontology shows that there is an error in it, it would basically show in red color that there is an issue with the concept and how no inference are associated with that specific class, and basically you can rectify it. And once the ontology is consistent, you would go to the next step of inferences that, now in this case, I have 4 defined object properties that shows which element is contained in which one, and then further the asserted object properties are introduced with the automated reasoner system. And for the completeness metric, the competencies are basically translated to Sparkle queries. You can see for what parameters are used for an algorithm X. This natural language is being translated to a Sparkle query showing the namespaces that it has. The select query shows basically what information we are looking at, and query modifier basically orders that information. Now, this is a snapshot of basically how the results are brought out. Now, it shows the type of algorithm that is being used, ANN and SVM, and then further the type of parameter and the name of the parameter being Adam is being used. Or if now there is another supplementary information to those, you will be getting a value on it. So it would be showing in terms of another triplet. In the last, I want to mention the contributions, the limitation, and future work of my study. So basically, at present, the contribution is creating this interoperability between BIM and BS, having an integration of the dispersed information system that can be used for the specific case of AFDD, and a model that is machine and both human readable and is a reusable source for AFDD. The limitation that right now I'm facing with AFDD is basically I cannot use the brick schema for the element level support. The limitations are linking the time series data with the AFDD ontology, and also the automated mapping between these two are not yet automated, basically. The future work would be how to extend and use the brick schema for the entire element level support, and enabling the AFDD ontology to be connected to the same time series data, plus adding the data types that are associated with those time series data to the model, and developing further use cases for state-related information concepts that are within AFDD ontology. Thank you, everyone, for your time.
Dr. Mosali, your sound is up, I guess.
Oh, yeah. So thank you, Arash, for a clear presentation, although we have some questions later on. And the topic is of interest, and I think it has a good application moving forward. So we're going to open the floor for questions and comments for the time being.
Thank you.
Questions or... I can start, but okay, I will just start with clarifications. Can you put the first slide on back, and we take a look at it? And just the first slide, the title of your presentation.
Yes. I think that really goes good.
No problem. If you cannot put it, just can you read the title?
Yes, of course. It's a semantic integration of BIM and BMS for AFDD, automated fault detection and diagnostics of HVAC.
Very good then. So this is a very general thing. When we say diagnostics of HVAC, what are you diagnosing during operation, during construction, certain functions that you are tracking? What is it that you are diagnosing?
Okay, thank you for that question. So for now, there are 13 competency questions that are targeting for AFDD AFDD ontology. So basically, the questions that are being asked is how, if an AFDD model needs to be redeveloped and reused by the user, it will allow us to basically bring in the information regarding the HVAC system, the type of algorithm being used, and its application basically within the building itself.
Yeah, Arash, sometimes
Operation phase of the building.
yeah, Arash, my question is quite simple. No algorithms here. What are you trying to diagnose in HVAC?
Example of faults.
Okay, so there are 18 categories of faults that are found within the literature, and for types such as flow type of faults, the opening or closing, any of those related faults are basically being captured in this model.
So that, in other words, you're trying to diagnose certain characteristics during operation of HVAC, correct?
Yes, that's right.
So it is not during construction, it is during operation. And this could be of value to the facility managers, for example, correct? The
Yes,
end user of your work is a facility manager.
Yes, exactly, to be precise.
Yes, now just for clarifications, and then I'll have other questions and maybe open the floor for questions by other professors and maybe comments.
Thank you.
So maybe I can go next if there is no immediate question. I want to follow up on the question asked by Dr. Mousavi. So do you see things that you do to be of any concern for the construction crew, for the construction team? Does any of the things that you do at all relate to the job of the construction team?
Not to the construction team.
Not at all? Where are the beams coming from?
Okay, it comes during the design and the construction stage. That's
So
right.
they are as-built beams, right?
That's right.
So can you tell me what lessons I can learn from what you do? Or let's say I am the HVAC contractor, okay, MEP contractor. From your work, what do I learn and how can I do my things differently, or what should I do differently?
Okay, so first of all, I think the user of this would be, before starting a project, it can have an insight of how things have been done prior in terms of the HVAC faults for a particular type of building, the spaces, the type of subsystems that are used. So basically, before getting into developing the HVAC system itself, you can know what type of fault detection methods can be adopted for the building that you are going to build.
So would it help me with type of information that I need to put into my as-built BIM?
Yes, that's precise, because you are able to bring the analytics from the AFDD of a similar type of building back into the knowledge model that can be reused for other similar type of projects.
All right. How about the information, operation information of mechanical systems like work condition, catalogs, I don't know, maintenance basically requirements and procedures. Anything there, any information from there, do I need to input into the BIM? And can your work show me what are those to be included for the later purpose of AFDD?
Yes, so there are two concepts that are being added already as a state that can be tracked. For those specific applications, the catalogs can actually give an input, so I would say yes. But right now, for my present state, it does not support that, but yes, of course it can be done.
Thank you.
Okay. Any questions or comments? Yeah, Dr. Chen.
Hi, Arash. Thank you very much for the presentation. My first question is, you got 18 faults from the literature, and then are these 18 faults from multiple literature sources or from a single literature source? My question, the reason for me to raise this question is that I want to make sure that the 18 faults are complete. Do you think they're complete?
Okay, Thank you for that question. The 18 categories are basically part of my first objective that I have done. It does not have all the concepts, not all the type of HVAC system, and basically it's only reflects the literature that I've analyzed. That's part of almost 72 papers that I've looked into. So it looks at those specific HVAC types and their faults, but I have extended it to have other type of HVAC system support, but not, at present, it's not an exhaustive list of those. And these are only to the studies basically that are using AFDD models for specific type of HVAC systems. So those faults for that which can be detected basically by the AFDD models, yes.
Okay, and in your developed model, is it possible for you to identify the faults that are not listed among the 18?
Sorry, can you repeat your question?
Like you're going to study among the 18 or 13, are you going to like do fault detection and diagnostics on the 18 faults, or you're going to do only part of the 18 faults, like 13, or only a portion of it? Or you're going to do the complete 18 faults?
Basically, the 18 subclasses that are introduced as a part of the faults concept in the AFDD ontology, I am only looking at, for the validation part, I am developing a certain, for my case study itself. So I'm not doing it for all the type of faults, but the type of faults can be extended. Basically, the ontology enables you to extend it for further faults, but as a case representative, I have used it for a specific type of HVAC, which is RTU, and the 10 VAVs that I mentioned in the case study, and the 7 faults that were found in that model.
Okay, and then on your slide number 4, you have a diagram, and then there is a bidirectional arrow. One is for more context, one is for more data. How do you define data and context? How do you differentiate them? Slide number 4.
Go to forest.
Page number 4.
Yeah, that's good.
Yeah, this one.
Okay. I would say that, so from my point of view, based on my experience, I might not have an exact answer to that, but what I'm defining context is the supplementary, the metadata that are pertaining to basically those AFDD that I'm looking. So most of the AFDD which I reviewed are basically purely data, in a sense that they were not having, they could not relate it back to the space that they were serving, the interrelatedness of those HVAC systems together as a whole. I'm not sure if I'm giving you the answer that you're looking for, but that's my opinion right now, what I can think of.
No, it's not very clear to me. I would expect a clearer definition of the data that you want to collect here in your research versus that for context. And I'd like to know why, when you have a lot of data, you can only do black box analysis instead of calibrated analysis simulation.
Okay, I might be able to give my input on that. Basically, the type of data that I'm talking about, data-driven, are the time series data that are coming from BMS. And for the simulation part, type of information such as, let's say, the occupancy information, the whether anything metadata related information are not basically in the models that I've looked at. So when I was looking at the BIM, how it could have contributed, I'm looking at those type of contextual information that can have meaning to the data-driven part of it. But I think so I'm not articulating exactly.
Okay.
So maybe if I can help, I want to just make sure that Arash got the question correctly. The question is, we have gray boxes, black boxes, and simulation-based, right? Three methods. What you're developing, is it meant to help all the three, or is it meant to help the black box and gray box?
Only
Black box and gray box. Okay, so the question is, why do you think this help? Number one, why black box and gray box need the help and not the simulation-based? And number two, whether your method can provide any helps to the simulation-based. If I understood the question correctly, Dr. Chen, right?
Yeah.
Okay, all right.
Okay. So basically, what I've looked the data, the AFDD portion of my study does not have so there were limitations when I analyzed the AFDD models were not being able to capture the information that are basically available in the simulation models. So my application is mainly targeting at that. So information such as the relationships, I was able to find it in a source, as I mentioned, BIM context part of it.
Okay, thank you. Can you give me a few examples of your defined data and also a few examples of your defined context?
Okay, sure. So maybe I can go to the context part of my.
Which slide?
It's yeah, that's the one. Thanks. Okay. So on the left hand side, I'm not able to show it on the laser point, but on the left hand side are basically showing the information that are basically coming in from BMS. That's algorithm, the features being used, the states and defaults, and the BIM contextual information that I'm talking is basically the element itself information, the interface that it is, the zonal information that it includes, the maintenance information, and supplementary information about the building and the HVAC itself.
Okay, and on this slide, you have BMS and you have BIM. And then for those boxes in between BMS and BIM, are they from BMS or are they from BIM, or part of them from BMS and part of them from BIM?
Or not?
Or not, yeah.
Maybe none.
None? Okay.
Okay, the ones in the middle, what are they? Are they coming from your ontology, or they come from BMS, or they come from BIM?
There are parts coming from BMS and BIM.
Yeah, because I'm more interested in knowing what kind of information you need from BIM and what information from BMS would you be able to achieve the automatic fault detection and diagnostics in your system, in your platform. And then since you are to identify different types of faults, and then is it possible for all of them to be detected using the same set of data and context, or for a specific type of fault, or for a small group of faults, you have to have some data that is not really required by another group of faults? Because you have so many different faults to be detected, right? Do all of them require the same information, or they may require different information?
Okay, I might just, if my understanding of your question is you're asking the information from BMS, all of need all the BIM information for detecting?
From both. Both.
From both. Okay,
yeah.
If they need both of them, for not necessarily all of them, but depending on what type of question that is being asked. Let's say if you need to know for competencies such as spatial information, yes, then you need for some of them. If it's only purely for a time series, then I would say some of them might not need.
Okay, and then for BIM information, does it have to be frequently updated, or you can use the as-built information for all the future detection, fault detection, and diagnostics?
Okay, the idea is to reintroduce basically the analytics back to BIM. So basically the BIM is being updated. at a certain frequency, depending at what HVAC maintenance requires. For that frequency, for depending each type of HVAC maintenance, it needs to be basically updated. Yes, so it would be updated. So the analytics, the whole point is basically reintroducing the analytics back to the BIM itself and referencing it with the BIM.
Okay, thank you very much. I think I stop here. I leave the time to others. Thank you.
Thank you. Okay. Other questions or comments?
So again, unless somebody else has a question or comment, I can
Yeah.
make clarification, because I think the
You
questions
think-
by Dr. Chen were
Dr.
very,
Liang?
very important. Just to be very clear, the black box methods, I think one of the questions that were asked by Dr. Chen was, what type of data are typically used in AFDD, in fault detection? So in black box methods or data-driven methods, is it common to take any contextual information of the system? Or is it just time series of data collected from the sensors that are used for fault detection? Which one is it?
Presently, only the time series.
Presently, it's only the time series, right? So the data that comes from BMS looks like a time series of temperature, humidity, noise, and so on and so forth,
That's
right? So your ontology is meant to add the
contextual
information. Okay, so can you give, because I'm not very happy with the types of examples that you gave. Let me help you. Tell me yes or no. The type of HVAC, type of mechanical system, and connectivity between different components, does it come from BIM or yes or no?
It comes from BIM.
Okay, can you help? Your ontology can help with that?
Yes.
Okay, which zone a specific part of subsystem is supporting the connectivity between the mechanical and spatial? Does it come from BIM, yes or no?
From BIM.
Can you give it to me, yes or no? Can your system?
It can.
The information about inspection, I go and inspect, I see there is a fault in some component, I replace it with a brand new one. Does this type of history get archived back in your BIM?
Yes.
Can your system help me with that?
Yes, it's being reintroduced.
Okay.
To the BIM.
And then I think the very, very important question by Dr. Chen. I have fault type 1, fault type 2, fault type 210. Each of these, are they all using data-driven? Are they all using the exact same features, or there are different types of features that are needed for detecting and diagnosing different types of faults?
For different algorithms, different parameters are being used. And again, the AFDDOntology can capture those features, the type of parameters used for that specific,
Okay,
and
so
the type of faults that
that
are.
knowledge is also recorded in your ontology. So I know
That's
if I'm looking for, I don't know, the foul on a certain component of my system, your ontology can tell me these are the features to look at, these are the parameters to basically calibrate. Is that
That's
right?
right. With
Okay.
the values.
Right. Thank you.
Sorry, I have a question. Okay, we have a question here from Simon.
Yes.
Okay.
That you use the building topology ontology and the break ontology, right?
That's right.
And the break is related to the operation phase, and one of them is related to construction and design and planning. And merging the ontology is an important part of your work. Could you please tell us a brief overview of your merging these two ontology?
Yes, sure. Maybe if I can go to the slide. Okay, 11.
Which number?
11.
11. Okay. Maybe. Okay. Okay. So this is BOT. Basically, what this captures is this is the upper level ontology that I'm using for BIM. So it allows me to capture information such as zone and interfaces. Basically, if an HVAC is being contained in a zone, and the type of object properties between the concepts. And again, I'm using another ontology, as you mentioned, for the operation stage, which is brick schema, that looks specifically at the HVAC system. It captures all the relationships of those. And again, I have created a mapping between BOT and element, being element is subclass of the HVAC equipment that relates to the BIM portion of it. So basically, I'm using BOT as the concepts that are already existing in BIM, and the bridge schema as the ones that are being from BMS, and whatever is missing are basically introduced to the ontology.
Okay. Dr. Liang has a question, I think. Dr. Liang.
Hi, Hassan, can you hear me?
Yes.
Yes, we can hear.
Okay, great. So it's like, since Dr. Moselli, Dr. Chen, Dr. Nick Beck, and also our on-site audience has already, give you a lot of questions, I will not like throw more questions to toss you, okay? But I do want to give you some suggestions that I hope you can think about. And I mean, first of all, it's only a suggestion. It's up to you, and because I do know it's like your future schedule and how much time you're gonna to hire before you complete your program or whatever. So my first suggestion for you is like to enhance your literature review. Okay, this is not only for you. Actually, this is for many students, because you want to clearly tell the people what's your contribution. I know in your slides you mentioned that, but for me it's not clear. Okay, or in another word, it's not convincing, persuasive, because BIM, no matter BIM, facility management, machine learning, this is one of the biggest subfield of our construction, right? There are countless people across the world working on this. You don't need to take care of everything just within your PhD study. You don't need to do that, but you really want to identify a niche, okay? You really want to identify, even though it might be very minor, a small piece, but you are one of the first people around the world that, as far to the best of your knowledge, identify this problem and make a small step forward. That's good enough, I mean, from my perspective, okay? So you need to make it very clear, okay? So for instance, for me, you may want to tell me, before you, is there any other people also try to work on using, this kind of BIM, machine learning to help detect the HIV fault, right? You are the first one or you are not. If not, you may want to say, what's the limitations of the existing works? Okay, so you want to make it very, very clear. So that's my number one suggestion for you. You want to, And number two is like, actually, I think all of my suggestions for you echo previous professors' comments. My second for you is like, you may want to take some advantages. It's like, I don't know, maybe you have some peer students also working in construction within or outside Concordia, or you have some student association, or whatever opportunity, or go outside, reach out to the people, actual industrial professionals. So you want to identify, the key is you want to identify a use case of your study, okay? We are engineers, so basically we are problem solvers, okay? You have I can see from your slides, you do a lot of work, hard work. But for me, again, it's not clear. You know what I'm saying? Just imagine I'm your, I'm a people coming to you for a solution, and I don't want to say that much details. That's too advanced, okay? I just want to let you tell me, using what data, in what circumstances, I can address what questions to what extent. For instance, what's your scenarios? You say it's commercial building, that's very good, but it's like, just like the defaults, right? Dr. Chen mentioned that the default, can you identify all the defaults, right? To what extent? And also it's like the data. You mentioned that small data, large data, but how to define it, right? And another thing that I want to share with you is like, actually, you mentioned you are advancing towards automatic identification, right? But the problem is like, so first of all, in general, automation, automatic identification is good. In general, that's no doubt. But to your study, you want to figure out which specific problem is especially suitable, or say badly need such kind of automation. I hope I make myself clear. Yep. Okay. For sort of questions, actually, this is not what I imagined. This is I'm sharing you my conversation with professionals before, okay? So it's like we work on something and the professional just tell us, you really don't need to do that. We don't need that fancy toy, okay? It's like based on our experience, we can just use, 5 minutes, take a second look, and then we fix the problem. But on the other hand, sometimes they would like to say, hey, we really need your help, okay? We are so confusing. And it's like, for instance, in our team, there are only one very experienced engineer can fix the problem. All the other guys cannot do that, or even the experienced guys cannot do that perfectly. So that's the point. Actually, this comes back to the first point that I talked to you. Enhance your literature review, okay? So it's like you want to find the niche. So that's my suggestion for you. And thank you. I think it's good. I can see a lot of efforts. Thank you.
Yes. Thank you, Dr. Liang. And you're right. This is for all students. It's not only for Arash. And I think the whole purpose of the seminar series is really to help our grad students learning about other topics, learning how to present their topic, how to defend their work, and also to take notes so you could really help improve the progression in your research thesis, be it a master level or a PhD level. I have another question for you, Arash. A number of researchers at the time being really trying to generate the as-built conditions in BIM. And of course, if you are to use that in facility management related operations, such as the one that you're embarked on, want to find defects and diagnose defects, then you need your BIM model to be as accurate as possible as built. And there is a difference between as designed and as built. And maybe a contribution of your work would be, yes, you can identify these differences, because later on, even in maintenance, if the layout is different from, instead of removing the false ceiling and then find the exact elements or component that you're looking at, or that would be of great help to the facility management team. So it's always helpful in the beginning to identify what will be the input to your model and what will be the output from your model, and who is the end user of that. That can simplify the case very simple. And then, as Dr. Liang said, and also before him, other colleagues, really to identify where is the gaps, where is your contribution to the body of knowledge between the input and output. What is happening there that you can, and not in the presentation for the seminars, you can present all your contributions. Maybe in this seminar, you're focusing on one thing. Also, the data need to be very clear. What are the structure of the data? What type of data? And would it be you're going to use it as it is, or you're going to do some cleaning of this data because some of these sensors could be defective and they may not give you the right signals? Or what are you? I know that you've done quite a bit of work here. Did you use any actual data from the facility management, say at Concordia, in the HVAC system?
For the data set that I've used is the FRP case study that I've selected, but not the Concordia's facility management data set.
Okay, but did you use any actual data in building your model as a prototype, or later on in testing it and validating it?
Yes, that's right. 2 FDD models are developed for an RTU HVAC system, and which consists of 10 VADs. Okay. And
but I think it's always for all students attending here, always the black box, not the black box that we're referring to in the presentation. What is happening between the input and output? This is what you are developing. And then what is it in that box that you claim as originality or contribution to the body of knowledge? You can identify. And in a seminar like that, it need not to be all of your research work or the output of all your research work. In today's seminar, I'm focusing on this particular thing, the data capturing, data analysis, training, maybe cleaning of the data, that is the kind of thing that you can use. Very good. So we're gonna have more time for about 6 minutes or more. Actually, we started late. We can entertain more than that, 10 questions and comments from faculty members and students as well.
Maybe if I may add just one thing.
Yes, Dr.
That's
Nikbat.
again, yeah, that's a lesson I think for everyone. It would be great to answer the question which is asked. Did you use actual data? Yes, I did. No, I didn't.
Mhm.
Can your method do this? Yes, it can. Can or no, it cannot.
Exactly.
That's
I
number
hope
one.
everybody's taking a note of that and writing it down. All of the students, I think. Yeah, because sometimes.
Number two
Yes.
is it's great to always know the audience of the presentation. I think are actually making a lot of assumptions that the audience here are building engineers, because I know that it's trivial question to building engineers. What is AFDD? Why is it important? Why what you're doing is a hair on a fire? Actually, we are now working with a company who came to Concordia desperately looking for help with respect to automated fault detection and diagnostics of HVAC. But it's always important, I think, to put it in context for the audience that you have. When you're presenting in construction automation lab for the construction team, I agree that you have to start with better clarifying, even though it's 15 minutes short talk, still it's needed for you to put things in a very specific context of what is the main pain, how you're contributing, who else has done what, why it's missing, and then focus on what you're doing. Even though I think you did a very great job in terms of presentation, but I think these were missing, and I think it's a good lesson for everyone.
Yeah. And another thing, maybe, I don't know, did you make a contribution in generating the as-built HVAC in the BIM model? Yes or no?
Yes, for the
Very
case
good. Some of the difficulties in doing that, in generating the as-built, because you're capturing information from the job site and trying to update your BIM model, correct?
Yes.
And in so doing, you may be missing certain things. You will not be able to capture all the information to give you the exact accurate as-built. And this is exactly, and you'll find in the literature, this is an issue that has been discussed. So I think, did you came across something like that, Arash?
I would say with respect to the HVAC, yes, not all information were what I was expecting. The case study itself had already mentioned about some of the shortcomings that's already been developed before. So there were some substitution that I had to do for my work.
Yeah. Thank you very much. And also, we need not to solve all of the problems. You could say not included in this research, X, Y, Z. I'm focusing on M and N, something like that. It would be very good. Very good. We have more time, as we said, for comments and questions, clarification.
And there are some people in the audience who do automated detection of these types of objects that can be very helpful for
Yes.
as-built.
Where is Dana? Where is Dana? Where is Hassan? Where is Shuru?
Yeah, Professor.
Yeah, you're doing a little bit of that. For example, Dana, you're identifying these elements and objects and stuff like that. Anyways, but we're not going to put anybody on the spot. Whoever wanted to speak or make a comments, that is fine. As I said, all the students, you need to be relaxed. This is a period where all of these seminars are there to help you, are there to provide you with a better background on a wide range of topics, so it would broaden your horizon in various related topics in construction, engineering, and management, and particularly on the automation side. And again, how to present your work and how to defend your work and how to take even feedback from faculty members. I hope every student during his seminar or the seminar of others are taking notes, because this is very good for you. Good.
In fact, this question has question, Professor Musa.
Yes, go ahead.
I have one last question. Since your developed platform is very related to, I think your data collection is very important to the detection and diagnostics of the faults in your, or that is the target of your research, as well as the target for future users. So I would appreciate it very much if you can tell the user what kind of data should be updated in the future, especially what data for BIM, what data for BMS. And then when you try to extract the data for your detection and diagnostics, which part of the data, required data, should be from BMS or which part should be from BIM. And then when you try to update information, are there any overlappings on data updating between BIM and BMS, or the two sides from BIM and BMS, you always get different information, or there might be some overlaps on information that you get from both the systems. Okay, so if you can make it very clear, and then people would know what kind of information they have to keep track of, and then they'll try to focus on those information, because time series data is important in this research, and you probably want to highlight on this. So you can always get useful information for your future detection and diagnostics. Okay, this is just one suggestion. Thank you.
Thank you. Very good. Any questions? We are on the, I would say, the as planned time of closing the seminar. But as I said, we started a little bit late. We could entertain a few questions before we leave, if there is any. No? Okay, thank you very much, everybody. Thank you, Arash, for the presentation. I hope you benefited from that. And the students also, I hope that you've benefited from that seminar. And thank you all for being here. Thank you, my colleagues.